Everybody today is using electrical cars, and a lot of times in electric cars, you don't have electric chargers. And if you do, it's one like this over here, which is a 110 charger. Say for a Generation 3 Tesla, that's only going to charge the car 2, maybe 3 miles per hour, which is not really very impressive. So what everybody wants today is called a NEMA 1450. This is pretty much the optimal charging receptacle for today's cars. It runs on 220 volts, and there's some significant wiring that's required to add this to your house. But if you want to do it yourself, I'm going to show you how to do it. Because my tenant that's moving in next week, he has a Tesla and he wants to charge his car in the house. If you're doing this and you have any kind of fear about working on a panel such as this, stop, hire an electrician, get an estimate, have a professional come and do it in your home. However, if you have some familiarity with it, you can do it safely. Just by all means, put your own safety and welfare first. So this panel here obviously has enough capability to handle the job, so I'm going to take that. In this case, I'm going to do a twin 40 220. I'm going to put this right there. You can see I have plenty of room for this panel. That's important. You don't want to overload your panel. And since a Tesla can only charge maximum at 32 amps, I'm going to use a double 40, even though this is a 50 amp rated circuit. That's my preference. You have to choose yourself which one is best for you. In order for me to do this installation, there's going to be some parts obviously required. So this one here I'm using, this is a 50 amp rated outlet. I'm using a 40 amp breaker, and what I have here is I have 8 gauge. It's an 8-3, which means it's 3 stranded core copper with a ground. So I'm going to run that to the back of my outlet. I have a twin 40 220 outlet, which is a square D for this panel because it's a square D. This one here is going to be your receptacle faceplate, which is going to cover the outlet like this. And I have this, I'm going to show you how to install this into the sheetrock. That's going to go like that, and that's going to be basically your wall setup. Then you're going to have some tools. You want to have a meter to verify your electrical conductors, make sure your work is proper, testing at the panel, etc. You want to have some of these connectors connected at the box and secure the wire from the fuse panel to the box. And just some basic tools. A flathead, number 2, also a number 1 in some cases, especially for those big lugs on that receptacle over there. Some wire strippers, cutters, etc. A level so that way you can have this nice straight installation in the wall there. And that's pretty much it. Not a lot here going on. First thing you want to do is I would suggest, for me, I would leave the power on, not just so that we don't have to reset all the clocks and all the stuff in the house. It's a major annoyance for me. But for the average person, I do not recommend you do that. First thing you want to do is go into your panel, turn off your main. So once that's off, close this off. You want to take your hand, hold it firmly onto the wall, remove all 6 of your screws, or 8 depending on your cover, then gently remove it. You don't want to have any metal potentially hitting another piece of metal in this panel when you're removing it. So you want to do that very delicately and very carefully. Okay, so I took my cover off, and then the breakers are switched into off position. I'm going to verify just by going from the ground to one of these legs. You got 123, 123. If you take that same thing over to here, you got 0, 0, 0. So basically, here up, you can get a little excited by touching those wires, but from here down, it's totally safe to work, and that's the position that we're going to be working. We're going to be drilling down and adding our receptacle right down here. So you can just plug in the car, have your cable draping down, and over to the plug on the back of the Tesla. Easy peasy. Okay, so there's my 2 legs of my 220. I got 110 there, 110 to this side, 110 over there. I got a square D because this is a square D 200 amp panel. I'm going to take that, click it in. There's your 220. So there's your one leg for 110 there, the other one right there. Nice and tight. Good to go. Now we just have to take out the knockout panels on the door panel over here that correlate to it over there, so that way when you put the panel on, these will be blank and you can install the cover. All right, so now my breaker's in there. I'm going to run my 2 legs down and over. Now you can see most of the circuits are going in the up position through the house, but I also have 2 which are running down. And since I want to be over here, I don't want to be in the path of this guy because my box is going to kind of like smush it. Same thing over here. So I want to go right down here in the middle. But down here, you can see there should never be any of this. This is all real bad. Any of these contaminants, sheetrock, metal, could be real bad. You don't want this stuff work in a nice, clean, organized, tidy area. So I'm going to work over here, which will allow for my mount over here in this corner. I'm going to drop down, over, and straight down, and this is where I'm going to put my box. This here I'm going to have to install. There's several holes in the bottom of this panel. I'm going to go right in the center since I'm going to go right in between these two circuits. I'm going to go right here, so I'm going to knock this out, install and mount this down, and I'm going to drop the wire out, and we're going to do our connection point right here. So we brought the outlet, we put it up against the wall, straight down from the circuit panel right there, dead center. We're going to level it, and we're going to trace it out, and we're going to cut it out with the drywall saw and mount that in the wall. Okay, so with my drywall saw, this was cut out. I'm going to take the box, and when you put the box in there, this one here, when you drill, it's going to turn these flaps up and it's going to sandwich this into the 1/2 inch sheetrock, which makes it stay in place. I'm going to take my wire, drop it down through one of these receptacles right here on the top, and that's going to go through here. And over here, I have this connector, which is going to secure my wire through the box, and then through here, I can take my hand through and I can hold the nut so I can secure it onto the bottom right here. But for now, I'm going to mount the box in the hole, then we'll start doing the wiring to the breaker. So I got my conduit ready to go through the box. I have this connector, so I'm going to basically slide this through. I'm not going to cut the wire through yet. I'm going to do that after I get through both sides of here and the box first. Okay, so I got that conductor connected through there, so I'm just going to take my extra wire, just kind of like lay it up in here for the time being. And then this, I'm going to run through the box, through this little section. You want to leave yourself enough little loop of extra in the wall in case, God forbid, you have to service it or extend it or do a repair down the line for the next guy. And enough to actually have come out of the box. Make your connectors on the NEMA connector. And sew it all back up. So once that's in there, get it orientated. Okay, once you got the wall mounted in there, I just took this and I kind of started a formation where the wires kind of twist and go around in a circle, so that way when I connect it onto this, since these wires are kind of hard and rigid, it's easy to push them back in, and if you have to pull it back out for service, it just undoes the loop. It's a joy to work on, if you can imagine a joy working on this thing. But it's least painful as possible, and I have this out there ready to go, so I'll run and connect the loop last, but first I'm going to do this. So on the back of your connector, you're going to have the two brass X and Y. These are both 110 legs. You have this one here, the silver, that's going to be your white. It's labeled right here, white, for your neutral return. And then you're going to have your green, which is going to be your bare grounds. That's going to be this conductor right here. So I'm going to connect these into here. Then I'm going to mount this up into the box. And when you do this, it's pretty important that you don't leave any excess wire. It should look something like this. And you want to get this in there nice and straight, centered as well as you could possibly get it. And that first tightening of the screw onto that wire is key, and I'll tell you why. Because you want to actually get that wire seated into the stranded wire, so that way it kind of creates a little bit of a pocket, so that way it can't get pulled out. Because from heat and contraction and just the house moving and just age, wire arcing, just natural occurrences, the wire can actually pull out backwards and create a bad situation. So you want to do that and kind of give it a little jiggle, get a little bit more on it. That's why I'm using this big screwdriver. Say, why is this guy using this gigantic screwdriver? It's for leverage, to get this into that socket as tightened and as well as you possibly can. So all my 4 connections are made. I have my ground on the green lug, on the white lug. I have my white neutral, and I have my black and my red, my 2 hots on X and Y of the 220 plug. I'm just gonna take that, give it a quick little twist here, and I'm gonna try to fight this thing back into the box. And then when you do mount this connector in there, you want to have the ground lug orientated up, because the Tesla connectors let the wires drip down. So you don't want to have a loop, you want to have it straight down. So you want to have your plug orientated like this. Now we got the outlet mounted. We're going to take the plate, use the finishing screws. Okay, all the wiring in the box is now complete. You can see it's going through my insulated conductor, coming up, over, red and black. There's my 110 leg here, 110 leg here. There's my 220. And over here in this house, I have a common bus bar where the neutral and the ground are. So I just follow what the electrical in the house has currently. That's done. So now we just have to put the panel back on. I'm gonna turn off all these breakers. Then I'm gonna turn on the main breaker and turn on each one of these things subsequently, because you don't want to arc the panel or cause any kind of disruption in the power grid here. So I'll do that now, and then I'll test this plug out with my multimeter, make sure everything is good. Before I sew this thing up, I'm gonna just test my voltage on this. Go from neutral to the right leg is 122 on voltage. Left, we got 122, perfect. Perfect on the ground. Again, perfect. That's it, there's our breaker installed. It's a wrap. Let's charge some cars. And when you do electrical work, do good electrical work. Make sure you notate your new work, so that way the next person that occupies a house knows what's going on. So I will call this the NEMA 240 volt. There you go. So there's your NEMA outlet done.